Okay, lesson 5.2. I'm going to break this up into two lessons. So I'm going to do part one right now, and then we'll do part two later on. What you're going to have is a copy of the PowerPoint. And as I work through the PowerPoint on certain problems, you will do the solutions to these problems right there on your handout that I give you. I'm just going to print out the slides for you, and then you'll work out these problems. And some of them I'll do with you on this lesson, and some of them you'll just do on your own. Okay, so for part one, we're going to go clear up through slide number 7, and the second part will be from that point on. Okay, so let's go ahead and get started. Perpendicular bisectors. Lesson 5.2. How do you find the point of concurrency of a perpendicular bisector of a triangle? Well, that's going to be answered in part 2, so you'll just have to wait for that. Students will be able to find the point of concurrency of the perpendicular bisectors of a triangle. Okay, so one of the things you need to know for this lesson is you want to recall what a bisector is. Let me see. A bisector, just what is a bisector in the first place? Well, remember back in chapter 1, if you have a segment bisector, it might be a line or a ray or another segment or a single point. But the point is that the bisector always cuts something right smack in half. So if you have a line that's coming through like this, imagine that's a straight line. And at this certain point, there's this point of intersection. If this line is a bisector of this segment, say AB, then it turns out this point here would be the midpoint, and this would have to be congruent to this. Okay. In the event that this line that's coming through is perpendicular, like maybe this one would be, whoa, let me do that. Back up. Like if there's a line that comes straight down like this, and it makes a right angle, and it still has this point right there in the middle, then that would be, of course, a perpendicular bisector, and we're going to get into that later in this lesson. So, anyhow, that's just reviewing what a bisector is and what a perpendicular bisector is, and later on we'll be talking about a point of concurrency. Sounds like money, maybe. Okay, we'll see that mainly in part 2. Okay, so these are some warm-up problems, and you see these on your handout. What I'd like you to do is take a few moments. You can pause the video now if you want. But I want you to go ahead and do this one on your own, and I want you to do this one on your own. And I want you to do most of this one on your own, but I want to show you how to set it up. You're going to have some of these problems on your homework, and basically you just need to be willing to draw a little picture. So you start off by just drawing a picture of this. So you have some sort of segment, right? And it has the midpoint, it has the endpoints A and B. So you know that because of this. It tells you the two letters, there's the segment symbol. And so those are the two endpoints. Now the midpoint, will let M be the midpoint. Well, if M is the midpoint, then you know something about it. These two sides must be equal. And see, so what you want to do is fill in this information. They're saying AM, this part, this portion is equal to 5x plus minus 2. And this portion over here, okay, is 3x plus 6. So now you want to find out the length of AB. Well, in order to do that, you are going to solve for x first. And so if these two are equal, then you can make an equation here. Just put in the symbol right here, equals, and solve for x. Now I'll leave leave that for you to do. So again, if you want to pause the video for a moment while you work on numbers 1, 2, and 3, you need to have those 3 problems worked out on your slides, your PowerPoint slides. And there's room on the margin here and there, and there's some room on the bottom of the slide here. So there's plenty of room to do those 3 problems, but make sure your work's neat, and make sure you put a box around your answer. And then don't forget, after you get X figured out right here, don't be a bozo. Only bozo stuff right there. My students always stop and say, hey, well, what is it that I'm trying to find out? I'm trying to find the length of AB. So after you get X figured out, you're going to put that X back in here, and then you can find the length of AM. And if you're smart, you'll just double that because these 2 lengths are the same. So there you have it. That gets us through the warm-up problems. Let's move on. Oh, let's move on this way. Okay, so here's the definition. A segment bisector. Well, I was just kind of covering that earlier in the lesson. That's something that cuts something right in half at the midpoint. Now, that could be a segment or a ray, but sometimes it will make a right angle in there, and so it will be perpendicular. And so we have a perpendicular bisector. And that's kind of what I drew earlier at this situation. So here's a segment AB. And here might be this point C. And the thing that's coming through here is straight up and down. And it creates a right angle. Then you know that this is a perpendicular bisector as long as these 2 sides are congruent. Okay? So there you have a perpendicular bisector. And of course we use M often for midpoint. We like to use letters that remind us of the word. And so we use M for midpoint. Okay, so let's move on. Excuse me, I'm allergic to something. So there's a picture also. Okay, so now we have a new theorem. This is an interesting theorem. Let's read it. It says, in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So let me kind of draw this theorem in slow motion. So you start off with a segment like this, you know, so you have a segment, okay? And so you have the points A and B. The next thing we draw is a perpendicular bisector. So draw a perpendicular bisector, and so we have a perpendicular bisector. Now it turns out, since this is a perpendicular bisector, that these 2 lengths are equal already. Now what this theorem is saying is that we could pick any point we want on that bisector. It can be anywhere we want. We can pick this one. If you pick a point here, we'll just call it C for a second. That can be anywhere on here. But if you take this and you draw a segment to the endpoints, okay, then what it says is that these 2 segments here are going to be congruent. That's pretty easy to prove. So let me just back up a moment and prove it to you. Okay. All right, so we have 2 triangles, right? And this is the right angle here, right? So we have a side, those 2 match up. We have an angle that matches up, and an angle that matches up. And we have a common side here. By the reflexive property, these 2 sides are congruent. So we have a side here and a side here. So by side, angle, side here, we say that the 2 triangles are congruent. And if the 2 triangles are congruent, then so are their corresponding parts. So this corresponding part matches up with this corresponding part. And so you have it. These 2 sides here must be congruent. And that's what's being shown here. And so you can pick any point on this perpendicular bisector, that point, this point way up here. If you connect those to the endpoints, then these 2 segments will be congruent. Fascinating. Well, now let's take a look at the converse. The converse is going the other way around. It basically says, look, if you have a point sitting out here and it's equidistant to the endpoints of your segment that you started out with, like this here, this is equidistant. If that is the case, then the perpendicular bisector will pass through that point, like that, right? So it says if DA is equal to DB, then D lies on the perpendicular bisector. So the point is that perpendicular bisector will pass through that point. All right, so you have this one, and this one is converse. Pretty easy. Let's move on. I think that's pretty self-explanatory. All right, so now we can start applying the theorems that we've learned. In this one, we have RS is the perpendicular bisector of PQ. Find PR. So we want to find this length right here, the length of PR. Well, that means we need to find out what X is. Well, since this is a perpendicular bisector, first of all, there's a right angle there. This side is congruent to this side. And if you read the last theorems on the previous slide, we realize that these two sides must be congruent then. So now it'd be kind of nice if you could stop the video and solve this on your own. If these two segments are congruent, clearly you can get a quick equation here. 8x, okay, minus 9 must equal 6x, okay? And so you just do some baby algebra here. We need to get the x's together. We need to put 9 over there, and we'll eventually get x figured out. So I think I'll just help you out on this one. So we subtract 6x here, subtract 6x here. This gets the x's together on one side of the equal sign, which is what we're trying to do. And right now you have x's on both sides, and that makes it difficult to solve for x. So moving them over here will make it a lot easier. So 8x minus 6x gives us the 2x minus 9, 0. And now the next thing we'd like to do is move this 9 to the opposite side. And again, to move things to the opposite side, or things like that, we always do what's called the inverse operation. The inverse operation of subtraction is addition. So to move this 9, we do add 9. So we do add 9 over here. And that gives us 2x is equal to 9. And finally, we divide by 2 here and divide by 2 here. And I think this gives us then that x is equal to, what, 4.5? Am I good with that? Pretty easy. Alright, well, so only bozo stops there. We were asked to find PR. So what we want to do is take this length and substitute in for x right there. And so if we take that length there, we're going to have 8 times x, which is 4.5. And then we're going to subtract 9. And that will give us the length of PR. So I'll just do this on my calculator real quick, save you the trouble. 8 times 4.5 is 36. So this is going to be 36 minus 9, which is equal to PR. And then I think this is equal to 27. Equal to PR. Okay, so you will have some problems like this, I'm sure, on the assignment. And that's how we do that one. So we're going to do one more example, I think. And let's look at this one. Okay, so this problem is kind of designed for that second theorem. A little bit anyways. In the diagram, JM, where's JM? Oh, JM is the perpendicular bisector. Oh, and someone came along and said that these two lengths are equal. Well, according to that second theorem, which is called the converse, this perpendicular bisector must continue and pass through L. It must pass through it. So there it goes, passes through L right here. Alright, that's what that theorem said. Okay, so the answer to this second part is yes. It is on there. And that's by that converse that we were reading about on that previous slide. Okay, so which lengths in the diagram are equal? Well, since this is a perpendicular bisector, it means that's a midpoint right there. So these two sides here must be congruent, right? So we could say HM is equal to KM. Okay, we have a right angle here and a right angle here. I think we could show that these two triangles here are congruent. And if we show that these two triangles are congruent, then these two sides here are congruent by corresponding parts of congruent triangles. So in addition to saying that those two sides are congruent, we could also say that HJ is equal to, oh, by the way, which letter should I use here? Corresponding part would be KJ. Don't forget those little skills that you learned in previous chapters. Okay, so that takes care of sample or example number 2. And this, I think, is a good stopping point. What we'll do is we'll do the second part of the lesson in class, but you'll have the first part done. And then what you'll do is you'll bring your PowerPoint worksheet that I've stapled all together for you, and we'll just finish that in class. We'll do the second half. And so that's it for now.